Okay, now that we've learned about holonomic drives and omni wheels and how they work, let's talk about the fundamentals of programming these drivetrains, in which there's kind of two approaches you can take with this. Some people will advocate that you need to do all this vector math and kind of determine exactly how to add these things together, and that is one way you can do it, and that is useful, especially if you have a non-standard kind of drivetrain, like something really funky where you want to add all the different things together. And to some people it might be appealing because it's kind of a way to almost program any drivetrain, but it's so much work and so much effort that you just would never want to do it that way. So we're going to take a simplified approach, and that's just that. So first of all, let me make some assumptions here. So we're going to be using two joysticks to program the robot, and that's it. Okay, so we're going to call this joystick 1 and this joystick 2. So this joystick, if I just approximate the dot up top here, like that, is going to control the direction we go in. So we can think of the x-axis as our x direction and the y as our y direction of the robot. And joystick 2, we're actually not going to use its y-axis, we're just going to use its x-axis. And we can think of this as our rotation. So let's just annotate that. So this is going to be our direction, and this is going to be rotation. Okay, so with that in mind, let's think about this. So actually, before we do that, let me make some assumptions here. So I'm going to assume that for both joysticks, that the joystick that you're programming has a center of 0, 0. I'm going to assume that left and right is your x-axis and is labeled as such, and top and down is your y-axis. And I'm going to assume that the up direction is positive, and the right direction is also positive for the respective axes. And I'm also going to assume that this has a range of approximately, for each axis, approximately 127 to 127. It's perfectly okay if the range is actually 128 to 127. Oops. Okay, because some things will do it that way as well. But for simplicity's sake, let's just assume it's 127 to 127, even if we know that it isn't. Okay. So the reason I say that I'm going to assume this is because I kind of have to assume this, because to be quite honest, different control packages do this differently. It used to be not the case that this was this way. It used to be actually, in the good old days, it used to be the case where the center of your joystick was right here. It was basically 0, 0 was over here, and so 255, it's basically unsigned, right? So 255 by 255 was up here, and the center was 127 by 127. So, that is the case for the version 5 microcontroller. Now, most of us aren't using that anymore, but that is how how things were when I did this. So it's not always the case that your input is nice like this. And if it isn't like this, then you want to get it to you want to augment it so that it is like this. Okay. So let's start off with the plus drive because it is the easier to program. So let's make a new page for that. So this is our plus drive, and let me just draw out one real quick. So we have simple plus drive, and that is pretty bad. I fix. Okay, there we go. Okay, so plus drive, and just like before, I will denote forward for our sake. And so if we want to drive this thing, oh, actually, there is one more, I forgot. So assumption I'm going to make, which is that I'm going to assume that, which this may not be the case for VEX in particular, but I'm going to assume that motor, if we look at the back of it, so like this would be the part that says motor, and then you'd have like your little standoff things. like this and a shaft that comes out here. I'm going to assume that when we spin it with a positive voltage, it moves from this perspective clockwise. So just like this. Oops, like this. Okay, now, if this isn't the case, which I'm not saying that the Vex motors do this, I tried to look this up, but I'm never quite sure. To be quite honest, when I tend to program these, I actually have I've seen that different motors respond differently, so I always have to kind of like plug some in and test them, and I just don't feel like doing that right this second. But let's just assume that positive equals clockwise, and a negative voltage or a value equals counter. Okay, so that's all we need, and that is, of course, from the reference of this, like this way. So if we're looking at the back of it, okay? And see, that's the problem, is some people like to think of it in terms of if you're looking at the front of it or whatever. So what this means is if we have a motor drawn from top view, which I will kind of denote like this, and we have little things coming up, what that means is that we're just going to kind of simplify it and say it wants to move this way if it's positive and this way if it's negative. Okay? Simple enough. Okay, so we have, with this drawing, 4 motors that are kind of attached to the wheels. If we want to move this forward, actually, let's label these. So let's just call these, let's just be simple. We're just going to be front, back, left, and right. So these are just names for the motors. And if we look at our diagram, we can see that if we want to move forward, well, that's actually really easy. We're just going to move this guy, the left motor, forward, since that's perfectly fine. And the right guy, we actually have to move in reverse, which I'll denote in red. So we actually have to go backwards. And the reason for that is because we can see that for the left guy, this is reverse, and the blue arrow is forward. And for the right guy, it's the opposite, so it's flipped around. So that this little blue dot is its forward direction. If you can kind of picture this positive being, if this was rotated, just 90 degrees, we can see that the forward for that motor's respect would be on this side. So simple to see, not particularly easy. Well, actually, we all know this. We all know that if you have 2 wheels and an axle, one of them has to be reversed. That's just the way it works. So we actually have an interesting relationship here where if we, in our config file, reverse this motor, we can put both of them forward. And so one argument is that we could just set these to be whatever we want. So if you're using like Robot C, for example, you can just kind of configure this to be, quote, the little reverse checkbox, and that's really an easy way to do it. Or in code, you can do it otherwise. So let's just, before we get started, well, actually, what am I trying to say here? Let's write down some things, is what I'm trying to say. So we can kind of say, that we're going to assign values to these things. So we're going to have left and right and forward and back. And so in order to move forward, we just kind of establish that whenever the y-axis is pushed positively, we would like the left motor to respond in kind. So for the left motor, it's just going to be, let's just give it y. Let's just kind of put that in there. So if we do that, let me do that a little bit nicer. Okay, so if we just give it y, then it will go forward proportional to y. What we've learned is that the right motor needs negative y, which is just a fancy way of saying let's flip it, basically. Like let's give it, so it's like negative 1 times y. We'll just take whatever y is and reverse the sign, basically. So if it was negative 20, it would become positive 20. If it was positive 20, it would become negative 20. So we're good there. And for forward and backwards, the front and back motor is what I mean to say. If we push on the X, so that's just Y positive. If we push on the X positive, we'd like our drive to go, of course, right, which is just a right-handed kind of thing. So a similar story exists here where the front motor is going to go positive, or should I say just regularly forward, and then the back motor is going to have to be reversed as well. So this should also make sense because this is negative here and this is positive here. And so if we actually look at the story, if I kind of put the dots here for all of these, what we can see is that these dots kind of just alternate, right? Like they just rotate with the motors. So again, it makes sense that we have to push one positive and one have to be negated. So in this case, for the front motor, we're just going to give it X, and for the back motor, we're just going to give it negative X. Super easy. Okay, so when we want to rotate, let's assume that we have our joystick and we just push it to the positive X direction. We would like the robot to rotate basically clockwise-ish. We'd like it to go this way. And so if we look at this, we can see that all the blue dots are in that direction. So that means all we have to do to rotate is we just have to add the rotation value, which we will just denote as R. So we've got, X is a label for the direction, X and Y axis, and we've got R as our rotation stick, which is a single axis. So we'll just have, it's a third axis. So all we have to do is add it to these values. Now, some of the smart programmers out there might be thinking, well, hey, Cody, can't the R value be positive 127, and can't the, either the X or the Y value be 127, and doesn't that, in this case here, doesn't that add up to be more than 127? And it does. But that's okay, because what Robot C in particular will do, and this is kind of one of our safeguards, is it will actually clamp this value to the maximum of what the motor can do. So it understands when you overflow, and it's okay. And to make matters better, Robot C will take in an integer as a value, and so the integer has more than enough room to store that and change, lots of change, and so life will be just fine. So we don't have to worry about any overflow issues or anything like that, because Robot C will just handle them for us. Now, if you really felt like you needed to make sure that those values didn't exceed, or if you're using a different package, you could always write a little clamp function or just use one of the built-in ones if they exist for your package, and you can just make sure that that value never exceeds positive or negative 127, and you're good to go. But for our sake, we're just going to assume that we're working with a full-blown integer, and that the firmware or IDE of choice, or whatever you want to call it, is going to take care of that for us. And so, like I said, in the case that if you're using Robot C, it will, and life is good. Okay, so that's a plus drive, more or less. An X drive gets a little bit more complicated. So let's see that in action. Okay, so for an X drive, we're going to have, let's see if I can do this. So we're going to have 4 wheels, more or less. And those are just a little bit off, so let me just kind of move that like that, and that's better. Okay, and likewise, we're going to have 4 motors. Oops. Okay, and just like before, we can see the red and blue dots, so we can just go ahead and put those in there to begin with. So the blue dots are going to be on the right of each motor. That's like really off, so I'll have to fix it. Let me... about as close as I think I'm going to be able to get, because these are kind of off, out of proportion. So let me just delete that. Okay. Oh, and I lost the motor. Okay. Actually, you know what? That's a horrible drawing. Let's try that again. Screw it. It's fine. Okay, so I need one more red dot. Actually, I need two more. Okay, so if we want to move forward with this system, actually, let's label the wheels first, just because we should. So I tend to do it like this. I tend to do front, left, front, right, back, left, and back, right. Okay. So if you want to move forward, like as if we push up on the y-axis positively, we are going to want the front left wheel to move forward, the front right wheel to move in reverse, and we actually want the back right to move in reverse as well, and the back left to move forward. So this is an interesting combination, so let's try to map this out. So over here we're going to do front left, front right, back right, and back left. Okay, so the front left, when we want to move forward, is going to be positive y. So we'll do some categories. So we'll do forward slash back, then we'll do left slash right, and then we're going to have rotation. Okay, and we can think of this as kind of like a table. Okay, so actually let's just start with rotation. Just like last time, rotation is always going to be just forward, so it's just going to be r. So we're just going to have plus r plus r plus r and plus r. So that's really, really easy. And we can see that because if we just move everything kind of in the blue direction, we get our rotations just fine. So we just move forward and we rotate. Easy. Okay, so if I want to move forward and backwards, we said the front left was going to have to move positive y. So this is for forward, and so the negatives kind of work themselves out, so don't worry about that. Let me just connect that better. Okay, if we want to move, so the front right's going to have to move in reverse if we want to go forward, so that's just going to be negative y. The back right is also going to be negative y, and the back left is going to be positive y. So a similar situation exists if we want to move sideways. So let's just erase this. Let's assume since right is positive, we just want to move right. That's right. And again, that's going to be positive x. So that's moving the joystick in the x-axis. You can think of it as like joystick like this, right? Like it's like if you push the joystick that way. That's supposed to be a joystick. Okay. So if we want to do that, let's see. Well, we want to move overall to the right, so we're going this way. So this wheel is going to have to move positively, and this wheel is going to have to move positively. This wheel is going to have to move negatively, and this wheel is going to have to, whoops, this wheel is going to have to move negatively. That did not work even kind of. Okay. And this one is going to have to move negatively. Okay, so now we can just map it out. It's really, really easy. This is going to be x, so our front right is going to move positive x. Our front left is going to also move positive x. Is that right? looks right. And it looks like our back right is going to move negative x, and our back left is going to move negative x. So kind of weird situation here, but if we can see the vectors, they work out. So we definitely, let's see, check, 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 and check. That looks right. Okay, so if we just look at the code here, what you basically need to do is we're just going to, if I'll just erase these bars here, all we have to do is basically just punch in these values. And like I said, they will overflow, but the system will catch it, and all will be well. However, you have to check your mapping. You have to make sure that your joysticks really, really are configured the proper way that we described here. And if your motor values are reversed, what basically has to happen is basically all your signs are going to be flipped. So if your motors go in the opposite direction, all of them, as long as you have them labeled like this, all of these signs flip, just because you just reverse the opposite ones. If your axes are different, then you kind of have to go through here and work it out, because some of the signs flip and some of them don't, and things get kind of screwy a little bit, but that's okay. Actually, let me just go ahead and erase the rest of these as well. And this, so we're just left with just these values. And the interesting thing is that these values are actually really, really easy to compute. Even in just integer logic, you don't have to do floating point anything. You don't have to do any craziness. They just work. Now, there is one kind of note here, which is that if we take the rotation joystick and we floor it like all the way over here to 127, well, for the most part, this is just going to make all the wheels rotate. They're not going to go any direction, and the robot will just spin, because we're giving a maximum rotation value. Now, it is technically possible to slam the, let's just say, the x-axis also all the way 127. And in this case, as we see, like on certain motors, like these here, or whoops, my bad. If we do this, in this case here, we can see that we're going to get, positive 27 minus a 127, so you get this weird effect. My recommendation is to essentially, well, you see, if you don't rotate all the way, you actually get a partial where you can actually rotate while moving okay. But if you do slam the rotation sticks all the way to the side, I would either avoid doing that or simply try to let off the sticks, the direction stick. That way things just kind of work out. I should probably denote this as an X. Okay. So one simple way you can kind of stop this phenomenon from happening is you could simply, as I mentioned earlier, kind of somewhere else kind of set R to equal maybe 1/2 of the actual joystick value or something along those lines. So keep in mind that this R value is going to be the actual value of the joysticks. So in some packages it may be like Vex RT, whatever, channel 1 kind of thing, or whatever. So these may end up being function calls. Now, one way you could kind of approximate is you could just say, R equals, I should say int R equals this value, which is fine, and then you can use R from then on, or you can do a define statement. You could define I think it's R, and then you could, the value xrt da 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 da. I have some code posted which I will share on this thread that should provide a decent starting point for any Holonomic project. It's code that is pretty much, I don't want to say the gold standard, but it pretty much does what you need to do for this kind of stuff. And aside from that, that's pretty much the basics. The only tricky part is just to make sure you get your signs right, and to really understand which way the motors are turning, and to really understand which way the joysticks kind of orient. And so just a little bit of playing around with printf statements and just watching the way things work can get you in the right direction. But this is pretty much the idea right here in a nutshell. So thanks for watching.